Hello. Today I'll be demonstrating a new Codex product capability that leverages machine learning to accelerate vulnerability prioritization and focus on the issues that matter. Codex is an application security workflow management platform which orchestrates the running of a suite of application security testing tools and provides a single interface to view and manage their results. It's good practice to use many different types of tools to ensure you are getting good vulnerability coverage. However, the amount of findings these tools report can be overwhelming, and the greatest challenge people face is the amount of noise and false positives they must weed through. After running security testing tools, a user is left with often thousands of findings. These are theoretical vulnerabilities. A highly skilled appsec analyst must go through each one and decide if it really matters or not. This process is known as triaging and is one of the most intense and time-consuming processes within appsec testing. An analyst needs to decide if the finding is a false positive, which is a tool saying something is a problem when it's not, or maybe it's real but isn't something an attacker can exploit. Or sometimes tools report noise, which are issues the organization feels isn't worth the effort to worry about. After this process, you're left with the findings that really matter, but getting there isn't easy at all. Let's talk a little about the problem with false positives. Microsoft conducted a study throughout their organization to provide insight into what barriers hinder the adoption of analysis tools. One of the leading barriers to adoption was false positives, and developers were asked what the largest rate of false positives they would tolerate before abandoning a tool. 90% of developers would be willing to accept a 5% false positive rate. That number drops drastically to 46% of developers for a 15% false positive rate, and only 24% would accept 20% false positives. It turns out the average tool has a 30% false positive rate. Google also published a study regarding their lessons learned from trying to gain adoption of analysis tools, and they found only a 10% effective false positive rate is acceptable for adoption. They consider an effective false positive to be any issue a developer decided not to act on for whatever reason. This will be much more than the actual false positives where a tool is blatantly wrong. I mentioned how triaging is very difficult. According to an IEEE security and privacy publication, it takes, on average, 10 minutes to triage each finding. That's not fixing the issue, that's just determining if you should try and fix it or just dismiss the issue as not relevant. And it turns out only 34% of those findings being reviewed actually matter. Let's dig a little deeper into that number. The National Institute of Standards and Technology, or NIST, has conducted many tool effectiveness evaluation studies over the years called the Static Analysis Tool Exposition, or SATE. In the most recent SATE data published, SATE 5, they evaluated 14 open source and commercial tools using both synthetic benchmarks and real-world applications with known vulnerabilities in them. They found the average tool reported 30% false positives and 36% insignificant, which are true issues but not really useful. This totals 66% of the findings that are likely irrelevant, and only 34% are findings that matter. There have been other studies that report similar results, many with even lower number of findings that matter. AppSec tools producing noisy results with many false positives is clearly a problem. Let's take an example of just one software application that is run through just one application security testing tool. A single tool typically produces around 10,000 findings, 66% of which are irrelevant. And we know that on average it takes 10 minutes to triage just one finding. So that's 200 days reviewing findings, 132 of which are spent reviewing ones that don't matter. And this is just for one application. Many organizations are managing hundreds or thousands of applications. And this is just one testing tool. Best practice is to use a suite of tools, since otherwise you will have blind spots. So how are you going to scale with this problem? You can't just add more people to review each finding one by one manually. That is costly and timely, and where are you going to find that skilled staff? Let's see how Codex's machine learning can help you focus on what matters and make your process more efficient. Let's say you have several applications that are getting scanned. This gets sent to an analyst to review, as you are probably doing today, where he or she will flag some findings as important and others as irrelevant. That information, along with descriptive feature information about the findings, are sent to Codex's Triage Assistant engine. Machine learning is then used to automatically recommend which findings to act on and which to ignore based on prior triage decisions of similar warnings. These predictions are tailored to your organization across all your tools and applications, and this can work within your firewall so you don't have to be concerned with sensitive data being exposed. So now, instead of a human analyst performing triage, Codex's Triage Assistant automatically predicts which findings are important based on past triage decisions. Every 240 findings automatically categorized saves 1 week of manual effort. Now let's see how well this works. In order to see how well our model performed and to help in the selection of the optimal model, we reached out to 5 of our existing users, as well as our own internal usage of Codex within our development process. This provided us with over 1 million labeled findings and feature data that we could then analyze. A portion of that data was used to train, then predictions were made on the remaining and compared with ground truth to measure the accuracy of the classification model using various metrics. One metric was precision, which tells us how much we can trust that Codex is accurately predicting irrelevant findings. For every time it said a finding was false positive, what percentage was correct? This is most important because it would be bad to report something as false positive if it was a true issue. Recall is a measure of how many irrelevant findings were predicted out of all of the irrelevant findings. How many false positives did it fail to identify? This is less dangerous since it would just mean someone would need to review a false positive. F1 score is the harmonic mean of precision and recall. And finally, accuracy is the percentage of findings correctly predicted as relevant or irrelevant. Codex averaged 99.31% accuracy across all the 6 datasets analyzed. The great thing about the way this works is the model is going to be created just for you as you use it within your organization and continue to learn on its own based on your specific usage and preferences. Let's see this in action. For this instance of Codex, we've already done some triage on other projects, and Codex has already trained based on this. By default, Codex will retrain each night, although you can also trigger this manually if desired. Let's drill in on the details of a single finding. Here we have a single finding that was found by Checkmarx, Fortify, and Veracode. Codex is predicting this as a false positive with an 80% confidence. This application may be set up to never be exposed on HTTP, and so making these code changes are less critical. Here I'm going to take Codex's prediction and mark this as a false positive. Let's take a more holistic view. For this project, we have 16,840 results from 12 analysis tools we ran. Codex has already been able to save us time by removing duplicates, reducing the number of findings 49% to 8,205, but that's still a lot to weed through. Since Codex already knows how we've triaged before, it's been able to make recommendations on which findings are likely not relevant. We can see each finding now has a predicted status along with a confidence between 0 and 100%. Taking a look at the predicted status filter, I may want to filter on the findings Codex has tagged escalated, meaning it predicts these are real issues. This could be a good way to prioritize what to look at first. In this case, though, I'm going to filter on what Codex is predicting to be false positives or insignificant findings, for which there are 3,069. Now I'm going to filter on only the ones that have 70% or higher confidence, and in bulk, I'm going to mark these as findings I'm going to ignore. This removes 2,315 findings. Assuming it takes about 10 minutes to triage each finding, that's saving us about 2 months of time beyond the deduplication time savings. If you're struggling with large volumes of findings to weed through and looking for automation to help improve your team's productivity and increase the adoption of analysis tools, give our latest version of Codex a try.